Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method, part 3. So let's get going. So we are given a differential equation of order 2. Here y double dash is nothing but d square y by dx square, or y double dash y2 is nothing but double derivative of y with respect to x. Okay, because here x is considered as independent variable and y is considered as dependent variable, right? And both equations in operator form is d square plus 4 into y equal to tan square 2x. So all these three equations are same here. Given differential equation, y double dash plus 4y equal to tan square 2x, or we can write this y double dash as d square y by dx square plus 4y equal to tan square 2x, or we can write d square y by dx square in operator form, say d capital D square y plus 4y equal to tan square 2x. Now take y common from the two terms of LHS, we'll get d square plus 4 into y equal to tan square 2x. Consider the equation in operator form as equation 1, which is in operator form f of d into y equal to some function of x, say r of x, where f of d is d square plus 4 and r of x is tan square 2x, right? Now we'll find the general solution of equation 1 using y equal to yc plus yb, and here we'll find yc using the auxiliary equation, and later we'll find yp. Okay, let's see. First we'll find yc, complementary function, using the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we are having f of d equal to d square plus 4. Let's replace d with m, so that we'll get f of m equal to m square plus 4. Then the auxiliary equation becomes m square plus 4 equals to 0. Now we need to find the roots, so we'll take plus 4 to RHS, we'll get m square equal to minus 4, then m equal to plus or minus square root of minus 4, which is equals to plus 1 into, we'll write minus 4 as minus 1 into 4 is equals to plus or minus square root of minus 1 into square root of 4. Since square root of minus 1 is I, so we'll replace it with I. We'll get plus or minus I into square root of 4 is 2. So therefore m equal to plus or minus 2i. The roots are complex conjugate. Okay, we know that when m equal to a plus or minus ib, which are the roots, then the complementary function looks like e power ax into c1 cos bx plus c2 sin bx. In case of a is 0, we'll get e power a into 0, that is 0 into x, right? Which is equals to e power 0 into c1 cos bx plus c2 sin bx. Since e power 0 is 1, so we'll get 1 into c1 cos bx plus c2 sin bx, which is equals to c1 cos bx plus c2 sin bx, right? Now just compare plus or minus 2i with plus or minus ib, then for b equal to 2 you'll get complementary function yc equal to c1 cos 2x plus c2 sin 2x. So we got yc now. Let's now find yp. Let yp equal to, now replace arbitrary constants c1, c2 by variables a and b, or functions of x a and b. We'll get a cos 2x plus b sine 2x. Okay, where a and b are functions of x and u equal to cos 2x, v equal to sine 2x. You can compare yp with yp equal to au plus bv, or you can compare yc with yc equals to c1u plus c2v. From this or this you'll get u and v, where u is cos 2x and v is sine 2x. Okay, and we'll find a using integral minus v into r of x by uv1 minus vu1 into dx, and we'll find b using integral u into r of x by uv1 minus vu1 into dx. Okay, if you observe, we are having uv1 minus vu1 in both the formulas. So firstly we'll find uv1 minus vu1 and later we'll go for a and b here using formula. Okay, let's begin. v1 is nothing but derivative of v with respect to x minus v into u1 is nothing but derivative of u with respect to x. This is equals to u cos 2x into derivative of v with respect to x minus v into u dash derivative of u with respect to x. U is cos 2x, right? This is equals to cos 2x into derivative of sine 2x with respect to x is 2 cos 2x minus sine 2x into derivative of cos 2x with respect to x is minus 2 sine 2x. This is equals to 2 cos square 2x minus into minus plus 2 sine square 2x, or we can write it as 2 sine square 2x plus 2 cos square 2x. Now take 2 common from these two terms, we'll get 2 times sine square 2x plus cos square 2x. Since we know that sine square theta plus cos square theta equal to 1, so we'll get sine square 2x plus cos square 2x is 1. So you'll get 2 into 1, which is equals to 2. Therefore, uv1 minus vu1 equal to 2. Let's now find a and b. We'll get a using integral minus v into r of x by uv1 minus vu1 into dx. This is equals to v is sine 2x into r of x tan square 2x by 2 into dx. This is equals to minus 1 by 2 into integral sine 2x into, since 1 plus tan square theta equal to secant square theta, from this we'll get tan square theta equal to secant square theta minus 1. So let's replace tan square 2x with secant square 2x minus 1 into dx. This is equals to minus 1 by 2 into sine 2x into secant square 2x minus sine 2x into dx. Now consider sine 2x into secant square 2x. We can write secant square 2x as secant 2x into secant 2x. Let's replace 1 secant 2x with reciprocal of cos 2x, because secant theta is equals to reciprocal of cos theta, right, into secant 2x. This is equals to sine 2x into cos 2x is sine 2x by cos 2x into secant 2x. Since we know that sine 2x by cos 2x is tan 2x, we will get tan 2x into secant 2x. So we can replace this term by tan 2x into secant 2x. Okay. this becomes minus 1 by 2 into integral of, replace sin 2x into secant square 2x with tan 2x into secant 2x minus sin 2x into dx. This is equals to minus 1 by 2 integral secant 2x tan 2x dx, minus into minus plus 1 by 2 integral sin 2x dx. Okay, here it's not necessary to write a integral constant because C1 C2 the arbitrary constants already appears from YC. Okay, so it's not necessary to write any constants here. Okay, and since we know that integral secant ax tan ax dx equals to 1 by a secant ax and integral sin ax dx equals to 1 by a minus 1 by a cos ax. So the above integral becomes minus 1 by 2 into integral secant 2x tan 2x for equal to 2. You'll get 1 by 2 into secant 2x plus 1 by 2 into integral sin 2x dx is for equal to 2. You'll get minus 1 by 2 into cos 2x. This is equals to minus 1 by 4 secant 2x plus into minus 1 by 4 cos 2x. So we got A. We need to find B now. We'll find B using integral u into r of x by uv1 minus vu1 into dx. This is equals to u cos 2x into tan square 2x by 2 into dx. This is equals to 1 by 2 into integral cos 2x into, since we know that 1 plus tan square theta equal to secant square theta. If you take 1 to RHS, you'll get tan square theta equal to secant square theta minus 1. So let's replace tan square theta with secant square theta in the next step. Okay, this is equals to minus 1 by 2 into integral cos 2x into secant square 2x minus 1 into dx, since tan square theta equal to secant square theta minus 1. This is equals to 1 by 2 integral of cos 2x secant square 2x minus cos 2x into dx. We can write secant square 2x as secant 2x into secant 2x. Okay, minus cos 2x into dx. Since secant theta is reciprocal of cos theta, so we'll replace 1 secant theta with reciprocal of cos theta. Then we'll get b equal to 1 by 2 integral of cos 2x into 1 by cos 2x into secant 2x minus cos 2x into dx. Right? Here cos 2x gets cancelled and we'll get 1 by 2 integral of secant 2x minus cos 2x into dx, which is equals to 1 by 2 integral secant 2x dx minus 1 by 2 integral cos 2x dx. Since we know that integral secant ax dx equals to 1 by a log mod secant ax plus tan ax and integral cos ax dx is 1 by a sin ax. Now the above integral becomes 1 by 2 into, for equal to 2, 1 by 2 into log mod secant 2x plus tan 2x minus 1 by 2 into integral cos 2x dx is, for equal to 2, you'll get 1 by 2 into sin 2x is equal to 1 by 2 to the 4 log mod secant 2x plus tan 2x minus 1 by 4 sin 2x, which is our required b. So we got a and b. Let's now find yp. Now coming to yp, we have yp equal to a cos 2x plus b sin 2x. Now substitute a and b here, where a is minus 1 by 4 secant 2x minus 1 by 4 cos 2x into cos 2x plus b 1 by 4 log mod secant 2x plus tan 2x minus 1 by 4 sin 2x into sin 2x, which is equals to minus 1 by 4 secant 2x into cos 2x minus 1 by 4 cos 2x into cos 2x is cos square 2x plus 1 by 4 sin 2x into log mod secant 2x plus tan 2x minus 1 by 4 sin 2x into sin 2x is sin square 2x. In the next step, we'll replace secant 2x with reciprocal of cos 2x and we'll take minus 1 by 4 common from these two terms. Yp becomes minus 1 by 4 into, since secant theta equal to reciprocal of cos theta, so we'll replace secant 2x with 1 by cos theta into cos 2x. Now take 1 by 4, minus 1 by 4 common from these two terms. I'll write it as minus 1 by 4 into sin square 2x plus cos square 2x plus 1 by 4 sin 2x into log mod secant 2x plus tan 2x is equals to minus 1 by 4 into cos 2x gets cancelled, minus 1 by 4 into, since sin square theta plus cos square theta equal to 1, so we'll get sin square 2x plus cos square 2x is 1. We'll get into 1 plus 1 by 4 sin 2x into log mod secant 2x plus tan 2x is equals to minus 1 by 4 minus 1 by 4 plus 1 by 4 sin 2x into log mod secant 2x plus tan 2x. Since we know that minus 1 by 4 minus 1 by 4 is minus 1 by 4, which is equals to minus 2 by 4, which is equals to minus 1 by 2. So we'll replace it with minus 1 by 2 plus 1 by 4 into sin 2x into log mod secant 2x plus tan 2x, or this term minus 1 by 2. From this we got minus 1 by 2, right? We can write like this also. So we got yp and already we have yc. Let's now write the general solution using y equal to yc plus yp. The general solution is given by y equal to yc plus yp, then y equal to yc c1 cos 2x plus c2 sin 2x plus yp plus 1 by 4 sin 2x into log mod secant 2x plus tan 2x minus 1 by 2. This completes the problem. So we have seen a problem from variation of parameters in this video, and we have seen the third way, that is part 3 here. I hope you'll understand. We'll see you in the next video. Until then, bye bye.